So the second part of our overview of Java Synchronizer's capabilities will be focusing on coordination and barrier synchronization. So coordination ensures that computations run properly in the right order. As we saw with our ping pong example, we wanted to have ping followed by pong and so on. At the right time. So you think about it like a real-time system, things have to run periodically at the right time, like you're monitoring the temperature in a nuclear reactor, or you're trying to make sure that your anti-lock brake system's working correctly and so on. And also under the right conditions. And this is actually what you're doing for your programming assignment 1B, where you're trying to make sure that the different beings are gazing into the fixed but smaller number of Palantiri under the right conditions when they're available, for example. Coordination in Java is supported by Java concurrent and locks packages. So Java util concurrent and Java util concurrent locks. So condition object, which comes out of Java util concurrent locks, and semaphore, which comes out of Java util concurrent, those support the coordination capabilities in Java. And we're going to spend a lot of time talking about them. They're really cool. You'll get a chance to play around with all this stuff in the programming assignments. Coordination is also supported in Java and has been since day one via its built-in monitor object capabilities. You'll get a chance to play around a lot with coordination, especially with respect to the Palantiri manager portion of all the B assignments you're doing. Then barrier synchronization is used to ensure that any threads, typically there's 2 or more threads, must stop at a certain point and cannot proceed until all threads reach the barrier. And this also works for exiting as well. So basically it's for entering something and exiting something. And you can think of barrier synchronization as being a variant or a generalization of coordination in one way or another. Barrier synchronization is supported by the Java concurrent package, by countdown latch, cyclic barrier, phaser, and so on. And these are really, really interesting classes. And I'm happy because we're able to demonstrate all of these different capabilities in the context of our Palantiri simulator app that we use as a running example throughout the course. So some of the stuff we're going to talk about at the beginning is not going to do all this complicated barrier synchronization, all of this sophisticated barrier synchronization. It's not really that complicated, it's just interesting and sophisticated. But later examples will be done using these different mechanisms. And I think you'll have a lot of fun playing around with them because they're very cool. For the most part, people who know Java and do concurrency, they know mutual exclusion. That's typically what they know. They might know a little coordination. They probably don't know much about atomic ordering. They probably don't know much about barrier synchronization. And that's okay for the most part because you can solve many, many problems in concurrent programming just by knowing about mutual exclusion and a little coordination. But as you get more advanced, if you want to optimize things, atomic ordering becomes important. If you want to work with pools or groups of threads that are trying to coordinate on something at a higher level, then barrier synchronization is important to understand. Barrier synchronization is also supported in a very modest way by Java's thread join method, which you're going to be playing around with for assignment 1A. So we use thread join in order to make sure that the program doesn't exit until all the other threads are done. So, of course, we're going to cover all this stuff in the course in great detail. I'm just giving you kind of the Cliff Notes, high-level view, bird's-eye view of all the different stuff we're going to cover. And that is the end of part 2 of the overview of the types of Java synchronizers capabilities.